Hi everyone, my name is Paul Ambrosiussen. I work at SideFX in the Games Team, especially on the game development toolset, which you might have used. There's a talk after this one by Mike Linden, which will go into detail and show all the new stuff that we've been working on for 17.5 and onwards. So I'll be talking about rapid level creation for Unity Mobile. So for this GDC, we did 2 projects. We had really cool Quixel projects, which you can see online at the YouTube channel from Quixel. Definitely check it out. And we also had our internal little game that we wanted to build for Unity Mobile, because we see that there are, Houdini usage in mobile is growing and growing, but we don't have a lot of examples for that. So we wanted to show you, this is an example of a workflow that you could use inside Unity or Unreal for mobile, but we decided to use Unity for this demo. So what did we do? We decided not to build a game from scratch, because that would require us to write all the gameplay logic and so forth ourselves. We could do that, but we wanted to show just the Houdini aspect side of things. So what we did is we took the tanks demo made by Unity Technologies and basically took that and wanted to give that sort of like an overhaul and Houdinify it. Everything you see there will now be generated with Houdini Engine and Photoshop in this case. So as you can see, it will now be Unity and Houdini Engine, and of course Houdini itself for the authoring of HDAs. So the game itself, it's nothing really impressive, but the part that we wanted to teach you is sort of a new type of workflow to build levels with. So as you can see, it's 3 types of biomes of a simple mobile game based on a tanks game. It's a grass level, it's a snow level, and it's a desert level. So there are lots of familiarities between those different types of biomes, right? So you have a tree in grassland, you have a tree with snow in the snowland, and you have a cacti, in the desert. And of course, all the aspects of the levels themselves, as enemies and so forth, also remains consistent throughout those. So this really shows you can use this for mobile games that have ongoing content creation needs. If you have a release cycle of every 2 weeks, you need more content. This is a sort of workflow that would allow you to do that. So let's say you want to build a mobile game or any other type of game. Typically, if you go through a traditional pipeline, you would start with something like paper prototyping, where the level designer creates a sketch of the level to just get a feeling of this is the type of level that we want to build. You could do this in Photoshop, you could do this on paper, you could do this any way you want. We decided to do it in Photoshop because of reasons you'll see soon. So imagine you just draw that white background being the level itself, right? Everything, the terrain and so forth. Then the gray area is for us the playable area where the player can drive around with. And then we just took a green brush and we drew some green strokes, which would be big props, trees in this case, brown for the road, gray for rocks and so forth. But we also included stuff like a blue dot or any other color, doesn't really matter, for a player spawn. So now, if you give this to someone else, a level designer who blocks this out, they would have a rough idea of how that level would look like, right? To just already start iterating on it. But what if you can actually take that sketch that you had and actually generate a functional level from that? So you have your Photoshop file, you drew all of that, right? So let's see how that works. We open Photoshop, create a playable level, the white background, like I said before, and then we draw our gray playable area. So the reason I decided to pick white and gray is we use that color as the height value for the terrain, because that was easier for us to create borders at the edge so the player wouldn't fall off, or we would allow the player to fall off. So we import that into Unity, and then with Houdini Engine, we tell it, take that PSD file and extract the layer that we called playable, right? Which is where we drew that background. And then what we do is we tell Houdini Engine, with the HDA we made, interpret that layer data as a terrain. So now already we have our 3D terrain from that Photoshop file, right? Next up, we tell the next HDA, this is the terrain, and this is the player spawn. So this layer we want to interpret as a spawn point, or just a point where we instance something. Could be a tree, but in this case we decided to instantiate a player spawn prefab. So already we were playing that, but of course we need enemies, otherwise there's no game, and we need some road to guide the player where to go. So once again, we create another copy of this HDA, and now we tell it, bring in the roads, and interpret that as a decal. And already we have a level with enemies, a terrain, and a road. So next up, it's too easy, so we need to implement some more gameplay elements, like for example a fence to make it more difficult to sort of force the player to be in a specific region to hit the enemy. So already we now have our fences in game. We just instantiated prefabs of a pole and some more wood, right? So now it's too hard. So this is where this sort of workflow shows the ability to really quickly iterate upon something that you made. So we saw it was too difficult, so what we needed to do is make it somewhat easier again by simply removing a little bit of that Photoshop layer, which would be those fences, right? Next up, I will just draw some trees and bushes and so forth. And already we have a sort of feeling of what this level might look like in the end after it's gone through a polish phase, which we didn't do for this project, obviously, but you can do that. And since it's procedural, we can now, instead of using that proxy geometry we had, just tell it, instead of those trees, use this type of tree. So the trees you see here are actually from a Unity asset pack that we bought online and just use that for the demo, right? So all these 10 different levels you see here, that took maybe half a day or even less, maybe 2 hours to draw all of those levels. And already we had 10 playable levels to play through. So very quickly we could push out a build from Unity using Cloud Build, and already we could test it on our mobile device. So let's go into detail about how this works. So you saw that we had a Photoshop file, right? And a Photoshop file has layers. And all those layers, we can give names: playable, trees, turrets, rocks, and so forth. And then for our purposes, we just decided to color the trees green because it's easier for us to understand. But you don't need that to be green. The logic of extracting in layers is separate from whatever you do after with it. So the terrain that we generated is just quickly, we made an HDA that takes a flat plane or a shape, extrude it up, voxelize it, and then do a remesh, which gave that triangulated look. So that's the bottom right you see there. For the road, we made another HDA which interpreted a layer as a decal, which then takes a terrain as input, it takes a PSD layer as input, and then projects that decal onto the terrain itself. So you have a road that follows the terrain itself because it doesn't have any height information, right? Next up, for the trees and the rocks and so forth, we also made like a scatter tool, really simple. It's just extracting that layer, have a scatter node, and it would scatter points with proper attributes so that it would instantiate whatever you told it to instantiate inside Unity. And similarly for the turrets and the player spawn, you can also take a big shape and then generate a center spline and create a single point in the centroid of that shape, giving us for every single red island of the turret dots, a single turret or a player spawn on the blue one. Well, that was inside Houdini. So inside Houdini Engine, we promoted all the parameters that we wanted the user to have access to, and made this one really simple HDA where we had a drop-down where we could decide what the method is of interpreting the data, the things we saw, like the points, scatter, decal, terrain, the size, so we could easily change the size of the level that's being generated inside Unity, number of instances, which was useful for, of course, if the scatter region, how many trees do you want for this level as a whole, meaning that if you need to have a mobile level where you want to quickly downscale it for testing purposes or want to test what the limits are of a mobile device, you just change that up all the way to create a more dense looking scene. Secondary object that was used for the fences, because first we instantiate the poles, right? And then afterwards the pieces of wood between the poles. So that would be the secondary object. And that results in the prefabs that you see there in the top right, the terrain, roads, trees, rocks. So you have individual control over all of those as separate HDA instances of the thing you see there. For the level creation, like I said, it's really, really quickly to build these levels. And it's also really easy to visualize what those will look like, right? So what we did in our game is in the bottom left corner, there's a button that you can press, and it will pop up that PSD file and show it while you're playing it. So it's very easy. You can see these are the regions that I need to modify or iterate upon. And we made these levels really, really quickly by just drawing them. So this means that you can now give the power of Houdini to a level designer that doesn't necessarily need to know anything about 3D. The tools that he needs to use is Photoshop, which is drawing. And drawing is something that anyone can do. It might not be high quality art. I also create programmer art, but in the right hands you can do a lot with it. Even with these rough drawings, you can create functional levels. So once you have that, you could see that you could instantiate different types of assets, right? It also makes it really, really easy to instantiate variations. So if you now want to create, for example, a candy version of your level, you now instantiate candy trees, right? Or snowy trees, you now instantiate snowy trees. So this is what we used to create, the grass, the snow, and the desert landscapes. Or of course, if you just start building your game, you might, use some blockouts as a base to already, see what are the kinds of props that I will need in my mobile game, and how many different unique variations will I need to make the game look good. So now we have our level, we have our generation, right? We have our instantiating of assets. So let's now take a look at the generation of asset and the types of things with it in that region. So the first two tools actually are the sub GoZ export and GoZ import. So we did our blockouts inside Houdini, which is the ones you see on the left, the rocks and the trees. We just took a sphere and something and just pushed it and added some noise and so forth. And then we used the GoZ tool, which is part of the game development toolset, to bring it to ZBrush, sculpt it, add some high resolution detail, which is what you see on the right side. And then bring it back into Houdini for further mesh processing, like baking it down to a low poly object, extracting the maps you need, and so forth, adding snow caps, dirt skirts, and more, which you'll see on the next couple of slides. So once we have our high resolution mesh, we need to do further processing, like I said. So we used a SOP axis align, which just takes a high resolution mesh from somewhere and centers it on the origin, which was important for us for the baking process, so to make sure that the high res and low res are matched together. Color blend, which is a new tool that allows you to very quickly take two objects with vertex colors and blend between those. Measure curvature. We measured the curvature of the rocks and of the trees to add some nice detail to that, which we would bake to a map. And game res, which is a one-stop shop-stop node from getting a high resolution mesh all the way down to a baked object for game. So how does that work? Here we see GoZ. Once again, we use axis align to nicely center it if it was changed in ZBrush. We measure curvature to get some nice detail there. And then we blend the concave parts there with the dark vertex colors. And then with the curvature, we get those the highlights. And then later on with the color blend, we blend between those two. And with game res, we take that high resolution mesh and bake it down to something that will work for us on a mobile platform. So once again, since it's HDAs, you can fully automate this process so that if you want to now target a high-end mobile device, you can change the poly count settings on there, increase the resolution of the baked maps, and it will make it very easy for you to swap that. So we now have some of our assets, right? But they need to be embedded in our levels, because if you just have a rock and you put it on a surface, it will look weird. So we built two new tools that get commonly used: Dirt Skirt and Snow Buildup. Dirt Skirt essentially takes an asset and creates literally a dirt skirt, right? So here we see a low poly mesh. We see our fake placeholder terrain. And then with the dirt skirt, what it does is it creates this nice buildup of dirt. Could be dirt literally, or snow, or anything else, with vertex colors allowing you to blend between the material of that dirt skirt and the terrain itself, so you remove any of the harsh intersections between the terrain. So this is one of the tools that we use in Engine to very quickly artify our level or increase the polish of the assets in-game. Snow Buildup, once again, very easy tool, something that lots of people do, but we just wanted to provide a very easy tool in the game development toolset. You just plug in your asset, and you can specify the poly count, tweak the how much snow you want, and many of its parameters. So this is once again one of those tools that you just batch process through all of your assets in game, creating variations, one with very little snow, one with a lot of snow. This would be really annoying if you had to go to ZBrush and sculpt snow, add that, create variations like this. This is just an automated process that works perfectly for mobile or other platforms, depending on your needs. So there you see that level in Unity. And of course, these HDAs also work inside Unity, right? So, or Houdini Engine in general. So if you have an asset, you want to add snow, you drop down your snow generation HDA, and you can add snow to any object. Next up, we also wanted to improve upon our physics animation textures pipeline. So one of the things that we wanted to try and do is, what if we can actually generate physics animation texture animations directly from inside Unity? So we took our physics animation textures, and we did some nice scripting inside Houdini and Unity. A talk about that will be done tomorrow by me. But essentially, this allows you to take that HDA with a vellum sim. You point to, for example, a cloth, and you just have it drape inside the engine, and already you have your animated vellum sim inside Unity or inside Unreal or inside any other application that supports Houdini Engine. There's lots of these types of things that you need to keep in mind when creating gameplay-ready elements. Like, for example, it needs to have a collision mesh, it needs to have proper material assigns, it needs to have tags, perhaps a rigid body component. Those are all separate nodes and attributes inside Houdini that you can assign. So Alexei Kalinin, thank you for this video. He basically combined all of that into a single utility HDA, making it very easy for someone to quickly attach a gameplay script from within Houdini or within Houdini Unity to a gameplay object. We also built a building generator for this project, which will also be part of the game development toolset. These are just 3 very simple examples assembled by Minal Kalkrute, an intern at SideFX, with meshes made from a bigger building that we extracted pieces from, courtesy of Maito 78. So here's another example, and another example. So you can see the sort of variations that you can get. So how does it work? Well, you start with building modules, which is what you see on the right-hand side. We have a top ledge, a bottom ledge, we have a window, we have a door, we have corner pieces, and so forth. And on the left side, you can see a block out that the tool cut up into pieces so that it could assemble building modules, right? So this is the result that you get without doing anything. It will just use placeholder grids and pieces to create this block out where you can instantiate pieces to. But if you want to force specific building modules on there, like the ones you see on the right, you tell the module pattern of, for example, the ledges or the facade, the main facade face, use a window, a wall, and so forth. And it has some really nice controls on how it does that. So it does this using a pattern syntax. So you can, for example, say for the facade, I want these pieces to be instanced as wall variation A. Then I want wall variation B, and then I want wall variation C. And already you can see that it takes that pattern and instantiates it over that the facade face, right? But we didn't stop there. We wanted to introduce some more randomness to create variation. So it also supports wildcards. So if you have a building module called wall underscore A, wall underscore B, and so forth, you could also just say, or tell the tool, use wall underscore star sign, which will say, hey, I have all these variations of this module. I'll just pick a random one. Making it very powerful to instantiate pieces. So now you already have your base building, right? You have a building that has all sorts of properties for every single layer that you can also customize per floor. So if you say for specifically floor 1, I want to have these types of modules, or the floor has to be this tall, you can just override that. But you also want to have some more artistic control over how you want to do this. So usually what happens after this step is you bake it down to a mesh, and then you turn it into a destructive process where now you force a door or something else into the building to make modifications. So we built this hand-placed overrides input where you can essentially just take a building module. In this case, I want to have a door at the bottom floor, which would be very difficult to do with that pattern, right? You can't say wall, 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 door, wall, 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 wall. That would be very boring. So what you can do is you can just take that door and place it where you want it and tell the tool, I want that door there. And it will take into account that you want it there, meaning it will adjust all the different building modules around it to make sure that that door fits. So this example that you saw was gridlock, so it just replaced 2 pieces that fit perfectly. But the tool itself is not gridlocked. Your modules can be any size. You don't need to take that into account. So with this example, it now fits perfectly, but then I move it so that now those 3 windows, or whatever they are conflict with the door. So the tool knows, he wants the door there, so that's a hand-placed override. I will adjust everything around it so that it works. So in this case, it saw I can't put a window there anymore, it wouldn't fit. So it generated walls there for you with nice UVs for a texture or material or anything you want to apply. So now you have your building, and you can hand place pieces. But this would be very boring and repetitive if you had to do this for example, fire escape ladders, where you want it to be in a very specific location in a vertical direction. So we also build volumetric overrides, where you can basically just have a bounding box, put it somewhere, and tell the tool, within this bounding box, I want the tool to instantiate, for example, fire escape ladders or anything else you have, literally. It's up to the user to how they want to name those modules. And now already, without being destructive, you can now force that using volumes. So imagine taking that building generator and then scattering points or volumes, and then very quickly adding variations everywhere, like ACs or pieces of clothing hanging somewhere and so forth. So yeah, you can create really cool stuff with this tool, so I recommend looking at the tool. And of course, it's open source, so you can dive in and make changes to whatever you want. So one of the things with building modules and assembling them is you need to know, how long are they, how wide are they, and it's very difficult to measure those inside Houdini. So with something new called Python state since Houdini 17, you can actually build interactive tools for the viewport. So this tool is a Python script where you just click and drag, and it will create a line and actually measure the distance between those 2 points and show it at the bottom of the screen. It's very small in this presentation, but readable when you're just sitting in front of Houdini. Once you then hold Control and drag, it now measures angle between those 2 different lines that you measured. So it makes it very easy to measure stuff and create custom tools using Python states. So this was obviously used for the building module, where I just needed to know how tall is this module. For this example, I could just middle mouse and I would see the distance. But in the next slide, we can see that it's very difficult, typically in Houdini, to measure what is the length of this piece. So once again, with a tool like this, I just click a shelf tool, click and drag, and at the bottom, I now know, this is 1 unit, so I would need to have a building module that is 1 unit tall. Next up, for VFX, we also wanted to create sort of new approach to doing VFX. So instead of doing a fluid sim or a pyro sim and then decimating that and exporting out as fat, we tried and do it differently, where we had particles and animated those particles, instantiated low-resolution spheres onto that, and then added detail after we had a nice look with our animation. So that we could take our typical character workflow, where we have our high-resolution mesh, bake it down to a low-poly mesh with consistent UVs, right? Allowing us to create normal maps, emission maps, and so forth. So inside Unity, this is how that looked like. So once again, the simple shape and the complex shape. So as a review, the game itself, or the workflow, is fully Photoshop and Houdini Engine based. We did asset creation tools, so those are all part of the game development toolset now. I just showed very few of them. We added 13 new tools, so definitely check them out. Asset integration tools, automated asset setup, like for example, generation of prefab, which a talk will be about that tomorrow. Explored some simplified VFX workflows, and we also built VAD shaders for the new lightweight render pipeline inside Unity. Thank you.